Good morning. Today what we are going to be looking at is how to prove that various angles or sides or even triangles are congruent using just a couple more theorems. Now, the one that we're going to work with primarily today is the one that we haven't used in common definitions and theorems, and that is segment addition and angle addition theorem. And that just tells us that we can add together segments to make a larger segment or angles to make a larger angle. And we've used that before. In fact, we used that way back in chapter 2 in our old one. And there's going to be a few more theorems from this chapter 2 theorem sheet that can come in handy. We've already been using reflexive quite a bit. And we can use things like transitive as well to really help us fill in some missing blanks. So if you're ever really stuck and you're starting to get into the realm of algebra where you're adding things or subtracting things, you should really refer to this sheet. By the way, whenever we start dealing with numbers, anytime we're trying to go from congruency to numbers, don't forget these two theorems. We may have to use segment congruence and angle congruence theorem to get into and out of congruency and equality. So just don't forget about these two. Have them hovering at the back of your head, because those will come in handy. If you want, you can even write them down on this sheet so you have it all together. I already have segment and angle congruence theorem here because it's going to be used so much, but you can go ahead and add some of the other ones that you've used a lot, like maybe transitive would be a good one to throw in. But let's go ahead and try some of the proofs that use addition. The first one that we're going to try is going to be a little bit tricky because it has overlapping triangles, and overlapping triangles always throw us off. But don't worry, let's start by filling in the information that we have and seeing where that gets us. Now, when I have my given statements, they tell me what markings I can make. So I'll be able to draw in these markings without having to really do any extra step on my table. BA is congruent to EA, so this is congruent to this. I know also that CB is congruent to DE. And that is all of my givens. I need to prove that these two angles are congruent, C and D. Now that leaves me to a bit of a problem because first off, remember it's hard to prove that an angle is congruent to another angle unless you prove that triangles are congruent. So instead of trying to prove this, I'm going to start by just trying to prove the triangles are congruent, because if full triangles are congruent, that means that C and D could be corresponding parts that would be congruent. So I'm going to look for what sort of triangles I have in here and then maybe see if I can add in some extra information. Now I can see that I have a triangle here and here where we have CB into this like center point and ED into that center point. But you see how that has only one of my pieces of given information? That means that even though I might be able to add in vertical angles, it's probably not the one that the problem is intending because it's not using this. That does not mean it could not potentially be helpful in the future, but I'm going to try some other paths first and see if there are bigger triangles that might be more useful before I go back and try this one. So when I look at this, I notice that I also have an overlapping triangle here where I have ACE as one triangle and the other one ADB as my other triangle. And those contain both of the sides that were given to me. So it's more likely that I'll be using that. So I'm going to go ahead and separate those two triangles out in my drawing. All right, so I've gone ahead and separated out these two triangles. And notice how I have pulled out this shaded one, ACE, and I kept all of the markings on it so I could transfer over what was actually congruent. And I did the same thing when I did this green triangle, ABD, transferring over those markings very carefully so that I knew that everything was congruent. And when I did so, I noticed that A is exactly the same in the triangles because A is shared entirely. It took only 2 lines to draw it. Those 2 lines are the same in both triangles. A has to be congruent to itself according to the reflexive property. I also noticed that here I have a side then, an angle, and 2 pieces of another side. So really, I'm probably going to use side, angle, side. But notice that when you're using side angle side, you do need to say the entirety of a side is congruent to the entirety of the other side. And I currently only have two pieces are congruent to each other. However, if you're adding things that are equal, the end result will be equal as well. So what I'm going to be able to do is add these segments together to get that final side. Now I'm going to go ahead and fill out my givens first. And because I'm doing side angle side, I'm going to be really careful checking that I have the full side congruent. So I started with this first given side, BA is congruent to EA, and that takes care of that first side. I have put in my angle because that's a pretty nice, easy one. I've marked in that they are reflexive, it's shared. And then I started my second side, CB, and that is congruent to DE. Now comes the slightly tricky part. What I want to do is I want to add things. But when I'm dealing with adding things, I'm going to be dealing with equality. So what I'm going to have to do is I'm going to have to switch this into equality. The measure of CB is congruent to the measure of DE. And that is the segment congruence theorem. That allows us to switch between equality and congruency. By the way, while I'm at it, I know that I'm going to want to add the side BA and EA to each side of this. So I'm just going to put that in this same line. BA is equal to EA. And I'm talking here, of course, about the measures. Well, now what that allows me to do... Sorry about that, guys. Man, it's hard to find time to record. Anyways, so what we're going to do is we are going to add together these smaller segments. I want to add CB to AB to get the full thing. And I'm allowed to do that because I'm allowed to add equal things to my equations. So I'm going to do CB plus BA, which takes care of this side here, and I'm combining equal things, will still be equal to DE plus EA, which takes care of this side over here in my other triangle. And that is the addition property of equality. Next, I want to combine these so that they are one longer segment instead of just pieces of a segment. So I'm going to go ahead and say, well, AC is congruent to AD, or is equal to AD. And all I've done here is what we call the segment addition theorem because I've added segments. Now, I need it to be a congruency statement to fully prove that my sides are congruent. So I'm going to go ahead and switch this into congruency. And I know I can do that with the segment congruence theorem. Now I have enough, because I have my final side, to go ahead and say that the full triangles are congruent. So ACE is congruent to triangle ADB. And that, of course, is according to the SAS triangle congruence theorem. However, I'm not quite done, because this proof asks not for the triangles to be congruent, but for the angles. Thankfully, that step is probably the easiest short of the givens, because all you need to do, once you've proven the triangles are congruent, is state what you want to be congruent, and go ahead and tell me CPCF, because you know that if the points correspond, then if the figures correspond, all of the sides and angles also correspond. That's it for our proofs for today. Have a good one.